All right. Good morning again, everyone. So we're going to get started. Quick announcements as usual. So first announcement, PLQ2 is going to be released this week. So I told you last week that we were going to try to get into a regular routine with those. So the second peer learning quiz is going to be released on, well, technically it's already released, it's already there ready to take. But the deadline to take it is going to be Friday at midnight this week. And then you'll have until Monday midnight the following week to take step 2. I'm assuming step 2 is going to be easy because it's just reviewing your answer, reviewing, your peers' comments. So that should be okay. But let me know if the fact that it clashes with the GQ, causes problem. To take it, just go to that URL, and this time the loading page will show you all the links for all the quizzes that we're going to get until the end of the semester. Just click the one that you have been assigned. PLQ1 has been graded, finally. And this is a grading scale that I've been using for it. So 3 points for the correctness in step 1, 3 points for the correctness in step 2, 3 points for the justification in step 1, and then 1 point just for showing up in step 2. Okay? So this is subject to adjustment. I tried to come up with something that I think is fair. If you have feedback on that, don't hesitate. Okay? You're not going to hurt my feeling. Just mention what you have to say, like in Piazza, for example, so we can have a discussion about it. All right. Second public service announcement. I set up finally the policies in Canvas so that it drops the worst GQ grade, the worst IE grade, and the worst PLQ grade. So this is supposed to help you a little bit if you are like on the edge with your grade here in between 2 letter grades or below passing right now. You're just right below passing. That should help a little bit, okay? Don't rely just on that to pass the class. Like I said, we're dealing with the most difficult maybe module right now. So make sure that you push hard on this. And then we are going to have like 2 more modules after that are going to be a little bit lighter. One of them for sure, the other one arguable. So that gives you an idea of what's coming in terms of the effort that you'll have to put into it. What we were at in module 3. So we're almost done with module 3. Depending on how fast we go, we might be able to wrap up all the slides today for module 3. Or we'll have a little bit of next session. And then after that, as usual, we're going to talk about a piece of code. So whether we're going to do it live coding or whether we're going to use the slides, I have both versions ready. It depends pretty much on the time that we have, okay? But we will have a comprehensive example that's going to pull together everything that we discussed about during module 3. The last time, this is a topic that we talked about last. Method matching versus method binding. So the first thing that I would like to mention about that is that these are 2 mechanisms. Okay, these are not programming techniques. These are 2 mechanisms that are used actually by, respectively, the Java compiler and the JVM. The idea is that I want to get familiar with both and to know when which one is actually acting and to understand the difference between the 2. So we really quickly described method matching last time. And we talked a little bit about method binding. We are going to reiterate what we said last time, and we are going to add on top of it. Okay, try to make that comparison and that distinction between the 2 as clear as possible. In a nutshell, until now, there was no difference. Until now, the way that we looked at our code, we always assigned to a reference variable, a reference to an object, and that object was of a class that we also used to declare the reference variable. This is why we have been able to pretty much coast freely until now, and we didn't have to worry about polymorphism, and we didn't have to worry about method matching, method binding. In our case, we could go and work with the assumption that somehow the compiler, when we assign something to a reference variable, checks the type of that something and make sure that it's of the proper class. That is the class that we use to declare the reference variable. So as long as there was a match like that, that was okay. Now if you think about it, last time with polymorphism, we broke that rule. Okay? With polymorphism, we said, oh, you declare a reference variable of type, let's say, A. Well, I can, of course, create an object of class A and assign it to it. That's what we've been doing all along. But then I can also create an object of class B or C or D. As long as B, C, and D are classes that are subclasses of A, then I'm okay. I can assign the reference to those object to the variable, the reference variable, that I declared as being of type A. So now I have the potential for a mismatch. This is why we have to be a little more careful about how we understand what the compiler is doing, what the runtime is doing. Okay? So let's put method matching and method binding side by side. And let's try to go over as exhaustive as I can summarize, of a comparison. So method matching is handled by the compiler. Once you are done compiling, method matching has done its job. It's not going to play again into the game. The idea of method matching is I want to make sure that what you write makes sense. So if you tell me I have a reference variable x, and I call a method m using that variable, reference variable, so x.m parentheses, okay? If you are calling a method m on x, what the compiler is going to do is, via the mechanics of method matching, ensure that there is indeed a method m based on the type, the data type that you use to declare x. So if you said x is of class, I don't know, faculty, so you call the method x.m, the role of method matching is to make sure that the class faculty has a method m. And that's it until we introduce inheritance. Once we introduce inheritance, then it's not only about checking the class faculty, because maybe the class faculty is a subclass. So if I don't find the method m inside the subclass, I'm going to go up to its superclass, look for m. If I find it, we're okay. It compiles. If I don't find it, I go to the superclass. And I keep doing that until I reach the class object at the top of the inheritance hierarchy. And then it's either the method m is there or it's not. If it's there, we compile. If it's not, compilation error. That's method matching. It's a check. It's a check done at compilation time. We have been seeing that in action with toString. Okay. Before we started overriding toString, we would call, x.toString with x being declared of class, for example, faculty, and it would find actually toString, not in the class faculty, not in the class employee, maybe if it's a superclass of faculty, but in the class object. So it had to go all the way up, but it did find actually that method that we were trying to call, and the check was passed. Okay? On the other hand, what we're going to call dynamic binding. Dynamic binding is not just a check. It's not just a check that what you write makes sense. Dynamic binding is, okay, the program has been already checked, it has been already compiled, now we are running the code, we are at runtime. And while we run the code, we need to decide on the fly which method of which class is going to be called. So when you write x.m to call the method m on the reference variable x, now there is an open question of which version of m do I use? The one in the subclass, the one in the superclass, and so on and so forth. So method matching cares only about there has to be a method m somewhere in the inheritance hierarchy. Dynamic binding cares about which of those methods, if there are several, should I actually call when the programmer wrote x.m. So this is necessary. We need that step. The step has become necessary because of polymorphism. Okay? Before, when you declared, faculty x, reference variable x on an object of class faculty, I knew it was going to be always method from the class faculty you were going to call. But now, I may pass actually to the variable x, I may pass a reference, I may assign a reference to it. That is not a reference to an object of class faculty. So now what are we going to do? Let's say faculty as a subclass assistant professor. There you go. Now I have a reference to an assistant professor. So yes, I know I'm going to find this method because of the relation between faculty and assistant professor. Okay, assistant professor does everything a faculty does plus some specifically assigned task. Okay, and I know I'm going to find the method. But the question is, what if I have two methods? What if assistant professor is actually overriding the method M that is in faculty. So now the data type of the variable tells me you are dealing with a reference to a faculty. But when I follow that reference, the actual object that I'm looking at tells me, oh, I am a kind of faculty. I am an assistant professor. You see the problem? So now, of course, the logic thing to do is to say, well, if my object is an assistant professor, I need to use this method. And this is what we have seen last time. We've seen that dynamic binding is going to favor, actually, the version of the method that is actually the lower in the inheritance hierarchy. Okay, if you give me a reference to actually an assistant professor, I use that. If you give me a reference to a faculty, then I would use the faculty one, of course. If you give me a reference to an employee, and so on and so forth. Okay, so it's really the data type of the object itself that matters. This is what dynamic binding is interested by. The data type of the reference variable is there to make some basic check at compilation time, method matching. The data type of the actual object that we reference, which may or may not be the same, polymorphism, that's what's going to determine which version of the method gets executed. So the Java compiler handles method matching. The Java virtual machine handles dynamic binding. One is at compilation time, one is at runtime. What they relate to, I'm going to skip that because it's not super relevant. I don't want to muddy the water. What we are going to look up to determine where to find the method. In the case of method matching, we look up the class that is used to declare the reference variable. It's just a static check during compilation. For dynamic binding, like I just said, we're going to actually be looking at the object that is being referenced and ask that object, what faculty, or are you one of the subclass of faculty? Because that matters to me. Okay? When we search for a match, we're going to search for a match by looking for the method inside the class that we target, in the case of method matching, so the class that we use to declare the reference variable. And if we don't find the method there, we look at the superclass, and we don't find it there, we look at the superclass, and so on and so forth. Well, this is where it gets confusing. This is why people often overlap the two and say, I don't understand the difference between dynamic binding and method matching. Is because in the case of dynamic binding, the same thing will happen. So let's do a scenario real quick, okay? I have this variable x declared as a faculty. So it's meant to hold a reference to an object of class faculty, but we know it can hold a reference to something different. Let's say that I put in it a reference to an object of class assistant professor, a subclass of faculty, okay, a special type of faculty. So now, when I do the method matching, yes, I'm going to check the class and its superclass, etc. I'm going to find a method M somewhere. When I do the dynamic binding, I'm looking at the type of the object. So I start elsewhere. Okay, with method matching, I started with the class faculty. With dynamic binding, I start with the class, actually, assistant professor. And I'm going to do the same thing. I'm going to look inside that class and say, is there a version of M that I can call? If so, yes, this is the one I want to call. If not, then I revert back to the superclass, faculty. If there's nothing there, I revert back to the superclass, employee. If there's nothing there, revert back to the superclass. In our examples, we have been using objects at that level. Okay? And if it's not there, well, if it's not there, method matching was on strike or something, right? Because method matching should have detected that there was not a method to be found anywhere in the inheritance hierarchy. So that should never happen. So eventually I will find a method M and I will call it. But because both method matching and dynamic binding are looking up the inheritance hierarchy, okay, a lot of people say, well, they're doing the same thing. No, they start at a different level. One starts with a class that's used to declare the reference variable, the other with a class that is actually the type of the object being referenced. And we know this can be different. Okay? So if match is found, if match is not found, I already covered this topic. That's the difference between the two techniques. Why does it matter to understand the difference between the two? Well, method matching matters because you are going to get compilation errors. Never skip compilation errors. They are trying to tell you something. If you don't understand what they are trying to tell you, you have an entire semester to come to office hours or post on Piazza and say, I got this weird compilation error. Here's my file. Please help me make sense of it. because it's not necessarily easy. It's not trivial. Compiler error messages are not meant for, they're not beginner friendly. They are meant for developers that already know everything there is to know about Java. So that's your training time. And then when comes the exam and you get a compilation error message, the deal is that you've been exposed probably to it, most likely to it, if you've done your practice exercise. Therefore, you're going to know exactly what the compiler is trying to tell you. If you ignore the compiler error message, you're just guessing randomly, right? So this is why you need to know when method matching kicks in and what it tries to do. And then dynamic binding, this is just to control what's going to eventually happen when your code runs. If you understand dynamic binding, then you can do some nifty stuff. I'll take an example towards the end of the lecture where we are going to write some very dirty code using a huge switch statement and stuff like that. And then we're going to replace that by almost no code, just relying on the property of polymorphism. To understand polymorphism, you need to understand dynamic binding so you know which method gets executed at runtime. That was kind of a review and expand from last time, okay? Like the last 5-10 minutes of the lecture, this is when we covered that kind of stuff. I wanted to reiterate and go a little further. Another thing that I want to reiterate a little bit, just to put it in context, what did we do until now with our polymorphic, let's say we have a polymorphic parameter to a method, okay? So we accept a reference to an employee. So we know we can get bombarded with actually an argument of type employee or an argument of type faculty, or assuming faculty has a subclass named assistant professor, then also an argument of type assistant professor. So we are like dealing with a polymorphic method, okay? What have we been doing until now inside the polymorphic method? Well, we took that parameter and we called some method on that parameter. And by the way, everything we learn about calling methods on that parameter would apply also to accessing its attributes, okay? Anytime you try to access a member of an object, it's going to be the same rule whether this is a method or an attribute. So we try to use something inside that object. So let's focus on methods first. What kind of methods did we call on our parameter? Well, the first one that we called was a method that existed only in the superclass. That was the case where method matching and method binding were like exactly the same thing. They were working hand in hand, okay? So again, you have a parameter, let's call it x, of type employee in a method. That's a polymorphic method. And inside that method, you call x dot. And now here comes the name of a method that exists only in the class employee. And that's perfect. The parameter was declared as an employee. The object that you have at runtime hopefully is an employee. You call a method defined in the class employee, no problem. Not even any polymorphism in sight here. And then we started saying, well, here's polymorphism. So now with this parameter x, I'm not getting actually a reference to an object of class employee. I'm getting a reference to an object of class, let's say faculty, one of its subclass, right? And so now dynamic binding kicks in, and I can actually call methods that are inside the subclass, overridden inside the subclass. So they are defined in the superclass, they are overridden in the subclass. Why do they need to be both? Well, they need to be defined in the superclass so that method matching works. Think about it. And they need to exist in the subclass so that I have something interesting to talk about that's differentiated from the first example. So I have polymorphism here in this example, okay? What is it that's left for us to consider? What kind of scenario didn't we cover? And I like to do this, okay? Whenever we look at a topic and there are like several moving parts, I like to go over all of the possible combinations. Some of them do not make sense, and I'll tell you. Some of them are not allowed, and I'll tell you. But by the end we do this, you have a full catalog of everything that you can do, everything you can write, and you know exactly which one are making sense, which one are not acceptable by Java, and why. So just for the sake of considering every possibility here, here's one possibility we didn't consider. We didn't consider calling methods on our parameter, on our polymorphic parameter, that only exist, that are only defined in the subclass. So they are not defined in the superclass, they are defined only in the subclass. Should dynamic binding be okay with this? What do you guys think? It's not the yes, no that interests me, it's more the reasons. Like, I don't think so because blah. I think so because blah, blah.
Should dynamic bindings more involved with overriding?
So right now, good question, we don't have overriding. Okay? So I have a superclass, let's say employee. I have a subclass faculty. There is a method inside the subclass faculty that doesn't exist in employee. Okay? And I want to call it on my parameter, on my polymorphic parameter. Very good question. My object is a faculty. The argument that I pass to my method is a faculty. The method say I'm going to accept a parameter which is an employee, superclass. What I passed actually as argument to the method when I called it is a reference to an object of class faculty, one of the subclass of employee. And inside the method I call, let's say the name of the parameter is x.m. And that m method, you look at the code, it only exists in the class faculty. It's not in the superclass. Should dynamic binding allow me to do stuff like that? Would that make sense to you guys? This is a way to kind of, think again about the definition of dynamic binding, method matching, and see if they actually make sense to you. Not sure? This is all too fresh?
I need to see it.
Okay. So need to see it, we can fix that. All too fresh, this is generally what happens, okay? But that's okay. We're going to run through those questions, those examples, just as a way for you when you restudy the slides to not only just absorb definition, but kind of question the definition and what do they mean in that scenario, what do they mean in that scenario, okay? So my answer to that one is going to be that dynamic binding should be okay with it. And that should is going to be the focus of the next 10 slides or so, okay? So it's not that trivial. But the reason for which I'm saying dynamic binding should be okay, think about it, okay? You pass a reference to a specific object, an object of class faculty. You pass it to a polymorphic method. Based on what we've learned about polymorphism until now, and dynamic binding, the idea of dynamic binding is that when this code executes, if my polymorphic method calls any sort of method on the parameter, it should favor the methods that are in the actual class of the object. If there is only one thing you need to remember about dynamic binding is, given a reference to an object, you don't even care much about how the reference variable was declared. You care about actually the data type, the class of that object right now. Okay, because we know it can switch at runtime. We can pass all sorts of reference to all sorts of objects. Well, let's look at what we have right now on the table, very concrete. Okay? So that's the philosophy of dynamic binding. So if I pass an object of class faculty and there is a method that only exists in the class faculty, I never encountered that problem before, but you know what? The philosophy of dynamic binding tells me that this method should be actually what I call, what gets executed at runtime. So it fits with the idea of dynamic binding. So it's worth exploring, right? Should method matching be okay with this? So that's different, right? I mean, that's the whole point of this slide, is that I'm trying to put the finger right where there is a difference and point it to you. So what's the difference again between method matching, dynamic binding? Method matching happens at compilation time, dynamic binding at runtime. Dynamic binding cares about the actual class of the object that you are referencing. Method matching cares about the class name that you use to declare the reference variable, or in our case, the reference parameter. Okay? So let's take a look at that reference parameter. That reference parameter was declared as a reference to employee, the superclass. Okay. So that means that I'm going to start checking for the existence of a method M inside the class employee. Well, that's going to be a bit of a problem. That's going to be a bit of a problem because here's how we set up our scenario, okay? We said we are going to call a method M on a parameter X. X is declared of the super type, and then at runtime we pass an object of the subtype, okay? So by definition we set ourselves up for failure, okay? X is declared of the class, in our example, employee. We said that the class employee didn't have the method M. This is the whole scenario we're exploring, okay? We're exploring what happens when I'm trying to call a method that doesn't exist in the superclass but exists in the subclass. And dynamic binding, makes sense in that context. But method matching, not quite. Because now we are in a situation where, by definition, we are not going to find that method in the superclass. Okay? Yeah.
So are you creating the method at runtime?
I'm not creating the method at runtime. It was written in the subclass. Okay? But it was not written in the superclass. So now that I get an object of the subclass, under the disguise of a parameter declared officially of the superclass, the mechanics of method matching is unable to confirm to me that this is okay. Dynamic binding, the philosophy means, run whatever is on the actual object. Yes, that would make sense. I could possibly run that method. And we're going to see that, indeed, I can. But method matching is getting in our way. Method matching, that little check that is done at compilation time, until now was completely innocent, never get in our way. Now suddenly, it's potentially getting in our way. Okay, it's potentially refusing to do things that would make sense with dynamic binding. So we need to take a little interlude here. We are going to talk about typecasting. How does everybody feel about the topic of typecasting on primitive Java data type? Just give me a quick thumbs up or thumbs down. Okay, no thumbs means two things. It's you are so you're in the middle, which is okay, or you don't even remember what typecasting is, or you never covered it, with your previous instructor. So I'm going to try to cover all the scenarios here. So what I want to do right now is I want to get you all to talk about how do we convert data types when we are dealing with reference data types. Okay, how do we cast a reference to a faculty into a reference to an employee? And the reason I want to get on that topic is because this is exactly what we need to enable dynamic binding to accept the previous scenario like it should, and method matching to shut up and let us actually play with that scenario instead of telling us, I cannot find the method in the superclass, end of story. Okay? So I need a technique here to be able to do that. So to be able to explore that new scenario I was talking about 5 minutes ago. So this is a technique I need. However, explaining that technique, if you are like a little bit blurry, on the typecasting, the topic of typecasting in general, or even the topic of typecasting, on actually primitive Java data type, that's going to be a challenge. Okay, that's going to be a challenge for you to understand what the hell I'm talking about. It's going to be a challenge for me to find a way to formulate things so that they actually make sense. So we are going to take a little detour. So we have like 2 levels of detour already, right? In order for me to explain that technique that allows me to get to that scenario I was talking about, I'm going to make a quick recap on data typecasting on Java primitive data types. So the Java primitive data types, you remember those? Int, long, float, double. All of those names start with a lowercase. Okay, these are not class names. Boolean, what else? Char, byte. I mean, there's like 5, 7 of them. Okay. All right. So what we are talking about here is I declare a variable of a certain data type, and I assign to it a value. That value has also a certain data type. As long as the value data type and the variable data type match, So for example, int x equals 42. The data type of x is int. The data type of 42 is int. Perfect. Does that remind you of something? As long as we assign to a reference variable an object of the class that we declared, everything is okay. So when you do those checks and balances, and the compiler does it every time, and the runtime as well, when you do those checks and balances, every time you assign a value to a variable, you check that the value has the same data type as the variable. And that's the easiest scenario. This is where everything goes super easy. This is what we start doing in COP2512. And if somebody tries to assign, something that is of a different data type, either the compiler yells at them, or I tell them, leave that be for now. Okay, hold on. Give me one more week, and then we can start talking about typecasting. Okay? So that means that when we have things like, for example, int vint equal 42, double v double equal 23.9, we don't need typecasting. The data types matches. But when we start doing things like v double equal v int, so I assign the content of the variable v int, which is going to be of data type int. I assign it to the variable v double, which is of data type double. So now checks and balances is not working so well. On one side of the assignment operator, I have an int. This is here. On the other side, I have a double. First observation, this is not the same data type. So we could say, if it's not the same data type, give up. Compilation error, end of story, we're done, right? But Java tries to do a little bit more than that. That's not just Java. Every single programming language, or at least the ones that I've ever used in my life, they are not going to just break down here and tell you, well, an int is not exactly the same thing as a double, so I'm going to blow up and give you a compilation error. Instead, they try to make things work. Making things work means I have to convert an int value so that it fits inside a variable of type double. So here's the thing about ints and doubles. Every data type, every primitive data type in Java has a range, right? All the numbers it can possibly represent if we're talking about numerical data types. So let's say int is this big. This is a range, positive, negative. Long would be a lot bigger. Double has an even wider range. So let's start talking about data type, or at least numerical data type, in terms of big and small, right? How many values can we store in this data type versus that other? Well, as long as you are trying to assign a small value to a large data type, it fits. Okay, common sense, intuitive understanding. I have like 2 cups of water. I try to put them into a container that can hold 5 cups. It's going to fit. I'm wasting space, maybe? You could argue day and night about that, but bottom line is that it's going to fit. No overflow of any type, okay? All right, so this is going to go without a question. This is called implicit type casting. When Java sees that you are trying to assign a value that is of a small data type to a variable that's meant to hold a bigger range, that data type, then it's okay. It's going to do the conversion for you. For example, the value, what do we have here? The value 42 is going to be assigned to the variable v double, okay? And it's going to become 42.0. So the way it's represented in memory, because it's a floating point number, it has to have a decimal part, so 42.0. Okay. Did we lose anything? No. 42, 42.0, these are the same. Java did the conversion on the fly. We are done. What do we have on the next line? We also have something that is implicit. Why do I use the word implicit, by the way? I use the word implicit every time I don't have, meaning the programmer, I don't have to do anything special. I assign v int to v double. I didn't use any special syntax, any technique, anything. I just assigned. And implicitly, Java rectified the potential problem underneath. And now I want to do the opposite. Okay? Now, inside the variable v double, well, I just assigned v double. So inside v double, I have 42.0. I want to assign that back to the variable v int. You could say, well, 42.0, let me see, as an int, that would be just 42. So I can do it. No, you can't. You can, Java can't. Java can't, because Java is not going to actually truncate anything. It's not going to lose anything. So if we try to do this, if we try to be nonchalant and implicitly put a value that is a double data type inside a variable that is just an int, so a big range data type value inside a smaller range data type variable, then Java is going to tell us, no, I don't think so. I'm afraid I may lose actually some significant digits. And think about it. If the value I had in v double here was actually what I had at the beginning, 23.9, if you try to convert 23.9 to an int, you lose the 0.9. You lose data. If you try to convert 42.0 to an int, you don't lose any data. 42.0 to 42, that's okay. It's just that Java doesn't know and doesn't want to take the chance. There is a potential for loss of data, for loss of precision, and just that is going to be enough for a compiler error message to flare up and tell you, there is a possible, I think the term is, possible lossy conversion. I could make the conversion, I could do the typecasting for you. But if I do that, we may or may not lose data. So I'm not going to do it every time, and I'm not going to say that your code is okay. You should take a second look. This is what Java is trying to tell us. Okay? So how do we get that to work? And again, it may be new, or it may be something old that you covered in COP2513. Okay, bear with me. If it's new, please ask question. How do we actually force that conversion to happen? We can actually, as a programmer, force the conversion to happen. We can tell Java, it's all right. I know what I'm doing. Yes, I'm assigning 23.9 to an int. I know I'm going to lose the 0.9, but I'm okay to accept that. I need to convert 23.9 to 23. Or I'm going to assign a value, but that value is going to be always 42.0 or 99.0. I know it's going to be an exact number. So trust me, convert it back to an int and everything is going to be all right. Based on the program that I'm writing, I can override the safety check from Java and tell it, it's okay, I know what I'm doing. Putting that back in context, what were we talking about 10 minutes ago? We were talking about method matching, which is a safety check that was preventing us potentially to do something that should be working from the perspective of dynamic binding. So we are right on topic here. We are talking about how we prevent safety checks that are conducted by Java so that we may actually have Java do things that we know as programmers are going to be all right. Okay, the syntax. Put the name of a data type between parentheses, for example, int, and use that to prefix an expression. So if I put that before a literal, or if I put that before a variable like v double, inside v double I have 42.0, right, by that time in the program. I'm going to convert that to an int, so 42. And I assign the result to the variable vint. Okay? Any question about those data type conversion? Sounds clear? Okay. So now let's move on to why we had this little interlude. So what I wanted to do is cast types. But I want to cast types that are not primitive Java data types. This time I want to cast types that are reference data type. So I have a reference to an object of class A, and I want to convert it to a reference to an object of class B. We're going to see exactly what that means and how it makes sense, okay? But this is actually my goal right now. What we can do, we can use data type casting among reference data types in Java. It's allowed. We're going to see about that, okay? But it has to be from a reference to an object of a certain class to a reference to one of its either subclass or superclass. So that means that the data casting happens between types that are related to one another via the relation of inheritance. And we convert references. I'm going to reiterate that 2 or 3 times before the end of the session, but I data type cast references to objects. You're going to see why that matters. So let's go back to the first remark about those data type being related by inheritance. So I have a little inheritance hierarchy here. So vehicle is its own class on the left. A university dweller is its own class on the right. A vehicle is characterized by the fact it has a method refuel. A university dweller, well, it cannot have a method refuel. It's called it. Okay? And then those two classes, they don't have any superclass. So you guys know that. That means they inherit from object. But then I have 4 extra classes in that diagram. So this is a UML class diagram, by the way. Very simplified. I have boat and plane. These are subclasses of vehicle. Okay? And then I have student and faculty, which are subclasses of university dweller. So I have side by side 2 inheritance hierarchy. So in case you never thought about that, most of our example to date, we use one inheritance hierarchy. And all the classes that we are playing with, they are related to one another, right? But nothing stops us from having 2 separate inheritance hierarchies, or 3 or 4. As a matter of fact, are they really separate? No, because everybody connects to object at the top. So it's like one giant tree. You had a question?
Yeah, so I was just thinking about that. So if like the vehicle and the university are both connected to the object class, couldn't you use reference passing to like a university dweller like part of the object class and then point it to the vehicle class?
Okay, and that's exactly what we are talking about. Okay, we're going to talk about what ways we can move in that hierarchy. And your suggestion was, can we go from university dweller to object and then back down from object to vehicle? So here are the rules. Can you go between faculty and plane? No. Even if you were going from faculty to university dweller, and then university dweller to object, and object to vehicle, vehicle to plane, those kind of series of conversion that end up pretty much converting a faculty class from a certain hierarchy, sub-hierarchy, to another class from another sub-hierarchy, they are not allowed. What else is not allowed? Even if you are inside the same hierarchy, you cannot even do one hop to the superclass and then go down. You cannot say, I'm going to convert from faculty to university dweller, then university dweller to student. That's not going to be acceptable. The common sense way to realize that, to internalize that, is to say that you cannot move laterally in any inheritance hierarchy. Okay, even for, like you proposed, we could not try to move laterally, but indirectly, go up and down. Well, that's still at the end a lateral move, so that's what we look at. We look at the end result. The end result cannot be a lateral move. So if we cannot do lateral move, if we could not do up and down, then we would be, out of luck here. There's nothing really to talk about. So we can do up and down. And we're going to start explaining up, and then we're going to move to down. Very simple structure for the rest of the session.
Sorry.
Yeah?
This is for all classes, languages?
Yes. So the concept that I'm going to talk about, upcasting and downcasting, okay, yes, it applies to any object-oriented programming language. Now, some of them are going to do things differently. So this is one of those topics where, depending on the programming language, you might have, to dig into it differently. You might have to learn it differently, okay? A lot of people think that, even like people that should know better, a lot of people think that, you can just take a language and replace it by another. That the design won't change, that the way of learning it won't change, that the way of teaching it won't change. The truth is that you can think that as long as you don't look into detail. If you don't know what you're talking about, pretty much you can think whatever you want and you'll feel you're right, okay? But if you actually look at what's happening in the language characteristic influence heavily how you learn it, how you teach it, and how you use it when you're trying to design an OOP application as well, okay? So this is one of those topics where, yes, this is the kind of stuff you would look at very actively. By the time you're done taking COP2512 and 2513, you would have been exposed to one programming language, Java. But I really hope that you guys have been exposed to it in a way that's going to allow you, when you encounter a new language, to immediately go into that textbook or go to that instructor and ask them the right question. For example, when I pass parameter, how does it happen? Is it by reference or is it by value? Okay? when we have polymorphism, how does dynamic binding work in this language? How does method matching work in this language? So if you learn even just one language, but instead of just trying to stay superficial, we try to actually dig just deep enough that you are exposed. You don't have to master, the internals, but just exposed enough to the internal of the language that you realize what makes the whole machine tick. Then immediately it's going to bring up questions when you learn a new language. And that's exactly where I want you at for your future, career in cybersecurity and stuff like that. Asking questions is always a good move. Well, we can rephrase that out of context, but for when we learn a programming language, yes, asking questions is always a good move. So, the first type of casting that's going to be allowed and that we are going to talk about is going to be the easy one. The one that goes well, like most of the time, all the time. It's called upcasting. That means you're trying to typecast a reference to a faculty, for example, into a reference to a university dweller. You are going from the most specific data type to the least specific data type. Remember typecasting between primitive data types? I told you when it's from a small data type into a big data type, it always works implicitly. Well, here what I'm telling you is when you are trying to typecast reference between two things that are related by inheritance, if you go from the bottom to the top, if you go from the most specific to the least specific, it always works. So Java will be able to do that automatically for you, implicitly for you. Okay? Quick remark here. I said upcasting permits an object of allows an object of a subclass type to be treated as an object of any of its superclass. So I allow an object of type faculty to be treated, and we're going to see what I mean by to be treated, okay? But to be treated as a university dweller. But I said any of its superclass. Why? Because the inheritance relationship is transitive. So if I ask you what is a superclass of faculty, the direct superclass of faculty is university dweller. It's on the diagram. But there are more. There is one more at least, given this diagram. Which one is it? Object, yeah. Indirectly, because university dweller is a subclass of object, and faculty is a subclass of university dweller, when I look at all of the superclasses of a class, I have to consider everything in the chain, right, up to object, okay? All right, so this is why there is any here. I wanted to clarify that, so just in case some of you wonder, or just overlook it and say, yeah, it's just bad phrasing, okay? No, it's not bad phrasing in that case. Why does this work so well? Because everything a superclass does, the subclass does it also. Every attribute is there, every method is there, and more. So because we have that superset, concept going on, a subclass is kind of a superset of the superclass, then, yeah, it's going to work. I can pass a faculty anytime somebody expects a university dweller. Why? Because faculty know how to teach, they know how to eat too. It's inherited. Students know how to learn, they know how to eat too. So anytime I pass an object, as a university dweller, whether this is actually a university dweller that knows how to eat, or a faculty or a student that know how to eat because they inherited that method, it doesn't matter. At the end of the day, every one of those scenarios, I have an object that knows how to use the method eat. And that's all I care about. Okay? Here's an example of upcasting reference. So we have a class, a main method, faculty F, student S. So these are the data type of the reference variable. Important for method matching. And then I create an object of class faculty, create an object of class student. Okay, say no more. This is like object-oriented, dream space here. Everything is going to be okay because I assign a faculty to a faculty reference variable and a student to a student reference variable. And then I declare a university dweller reference variable. So I use a superclass, okay, university dweller. And then I say I want my dweller reference variable to refer to the same object that F refers to. Polymorphism, okay? I want my dweller reference variable to refer to the same object that the variable S refers to. Again, polymorphism. University dweller variable refers to an object of class faculty in the first case, student in the second case. Okay? So there is upcasting here. There is upcasting because what I assign here is of type faculty, subclass, and I assign it to a variable of type university dweller, superclass. You assign something of the subclass to something of the superclass, you have automatic implicit upcasting. The reference to the faculty is going to be converted to a reference to a university dweller. Yes?
So the upcasting is only possible because of polymorphism, or does it make it easier?
I'm not sure if it's a chicken and egg thing, but what I would say is that upcasting and polymorphism go hand in hand. Okay? You can have polymorphism because you can have upcasting. If you were not capable to do upcasting, polymorphism would at the very least be a lot more complicated. We would have to have more notation and stuff like that, the kind of notation that we're going to discuss about at the end of this session. Okay? But right now, we don't have anything special that we need to use. Okay? The simple fact that we use polymorphism is also an example of us relying on implicit upcasting from Java. So Java has been doing implicit upcasting every single time we did polymorphism until now. Okay? That's a pattern in this course, right? We do things, we don't say too much about them, we just cover the superficial stuff, then we introduce a new concept that is more about how things are working under the hood, and then suddenly you turn around, you look at everything we have done until now, and you look at it differently. Yeah, this is exactly the pattern that I'm going for here. Okay? So in this case, now we can look at every example of polymorphism and say, you know what? Polymorphism worked because Java was able to do some implicit upcasting. I learned a new word. I'm going to use it right and left. Okay? No problem there. All right. So here's a common misconception. We were able, based on the previous example, okay, I could go home and think to myself, so I was able to successfully typecast an object from one subclass, faculty, to one of its superclass types, university dweller. And I would guarantee, I don't know, this is a strong word. I would bet, okay, I would bet that maybe like 70% or whatever, like good large proportion, 60, 70%, more than half of the student in this class would be okay with that statement. Because it's actually something that even like established programmer, we say that all the time. But you have to be careful. This is not a proper phrasing for what just happened. So the fact that I want to draw your attention to is we did not actually typecast object. Yeah, it seems like something innocent to say, I typecast an object. Did you transform actually a faculty object into a university dweller object? No. It's really important to understand that. All you did is you actually typecast the reference to the object. So one little metaphor that I use to try to explain that, to make it stick, okay, is when you typecast a reference to an object, when you have an object of class faculty, and you say, I have right now a reference to an object of class faculty, I'm going to typecast that reference to actually the type, what are we using? University dweller. There we go. What you did is you didn't change the object. You didn't transmute the faculty into something else. But what you changed is the way you look at the faculty. So start thinking about a reference to an object, the data type actually of the reference to an object, as the way you want to look at that object. And now that I have this kind of metaphor framework in place, let's look at a stupid analogy, because I love stupid analogies, right? There is a student with dreams, aspiration, the capability to do something in cybersecurity. They are like about to graduate in cybersecurity. They have a lot of skills in cybersecurity or IT or whatever. And they are in line at Subway. Behind them is a faculty. Again, dreams, aspiration, very complex individuals, both of them. And that faculty has a research specialization in, evolutionary computing. And so it has all those skills, those methods. So skills equals method in my analogy. Those two very complex individuals, faculty and student, are in line at Subway. They finally step in front of the person ready to make their sandwich. What do you think is going to happen? Do you think the person ready to make their sandwich is going to look at them as a student and ask them, so how is cybersecurity going? You know, I always wondered, if you have like a buffer overflow, does that mean this and that? No. They are not here to actually discuss cybersecurity with you. The contract that you have is, I'm going to step in, I'm going to tell you what sandwich I want, you're going to prepare the sandwich, there's going to be some money exchange, and then we are going to part ways. It's a transaction, right? So in that transaction, there is no room for all of your cybersecurity or IT skills. Same way when the faculty comes, imagine the faculty comes and he's asked, what kind of bread do you want? And the guy starts a lecture on, do you know that evolutionary computing was invented by John Holland? And this is like nonsense, right? So my point is that Subway person is looking at both objects, in my analogy, through a specific lens. The lens of, you are a university dweller. You roam around the campus, you do something on this campus. I don't know exactly what it is that you do on this campus, but one thing I know for sure is that every single university dweller on this campus needs to eat. They know how to eat. So you and I are going to talk about that. Okay? I'm going to, again, based on the analogy, I'm going to look at you as a university dweller object, and I'm going to only call the method eat on you, because that's guaranteed that it's part of a university dweller. Everything else that is making up the object, no matter how complicated, no matter how beautiful, is going to be ignored. That's what looking at an object in a certain way means. That's what looking at a faculty object or a student object through the lens of a university dweller means. That means I'm going to restrict myself to interact with those objects as if they were just simple university dwellers. And this is the base of polymorphism, right? I accept as a parameter a university dweller. You can give me any of its subclass. Sure, I accept it, but I still interact with that parameter as if it was just a university dweller. So upcasting is exactly what polymorphism craves. It requires upcasting to exist. It requires upcasting to function. Let's take an example. So here's a class polymorphism demo. Display object, static method inside of it. So this is going to be my polymorphic method right here. Okay, it takes an object parameter of type geometric shape. So we are back to the geometric shape example from the textbook. Okay, and we've seen already that example, by the way. Inside the method, I call object.get date created and .get color. So I call two methods that are defined in the superclass. And that works perfectly, okay? That works perfectly when I pass a new circle, when I pass a new rectangle. So we already looked at that example. Let's consider another example here that's going to introduce overriding. Because the first thing we did was looking at those examples from the previous slide and saying everything works perfectly without me having to think too hard. Then we introduced overriding, and then we talked about, hey, what if I try to call a method in the subclass that doesn't exist in the superclass? Okay, we're not yet there, but let's go and look at overriding now. Class super, yes, I was running out of IDs for name. Class zub extends super. Super as a M1 method, zub as a M2 method, and they just display, hey, this is a method that got called. So what I have here is I have a main. I declare a reference variable O1 of type super. So make the difference between the data type of the reference variable in your mind and the data type of the object that's actually being referred. So right now, O1 is of data type super, and it refers to nothing, null. So we don't have an object to worry about. Awesome. Then I declare a variable O2, and this is a reference variable meant to hold a reference to an object of class zub. And I create an object of that class, and I assign the reference to it. Again, no problem. Okay, no reference or like a reference of the same data type. That's easy peasy. I say O1 assigned O2. So O2 is a subclass, O1 is a superclass. That's polymorphism. I'm playing with polymorphism, so that means that now I'm looking at the only object that was created. Okay, the only object that exists right now is of class sub, the subclass. Okay, I'm looking at that object, and when I'm looking at that object with variable O2, I look at it as what it really is, an object of class Z, the subclass. But then, since I assign its reference to O1 as well, I can look at it through the eyes, through the lens of variable O1, and the variable O1 has been declared as a super type. So I can look at this object as if it is actually an object of the superclass, or as if it is an object of the subclass. And that is independent of the reality. The reality is that, yes, it is an object of the subclass. You see the difference? Okay. What do I do after that? Well, I use O2, and I call M2. So M2 was declared in the subclass. I call the method M2 that was declared in the subclass using the link to the object that looks at it as an element of the subclass. It works. M2 was not even existing in M1, and that actually doesn't pose any problem. So dynamic binding is okay with that, method matching is okay with that. And then when I call O1.M2, this is where I get a little bit in trouble. Because now I'm using the variable, the reference variable that says I'm going to look at whatever I refer to as if it is an element of the superclass. And even for the object I'm actually referring to is an object of the subclass and as the method M2, when I write O1.M2, method matching breaks down and says pretty much, I tried to check if method M2 made sense, called on a variable O1, but because O1 is of the superclass type, it doesn't make sense. I cannot validate. It's not that it's not possible, because we know it's possible, okay? But it's just that I cannot validate that for you. Java, the Java compiler, is not smart enough to be able to read the whole code and figure out that, yes, it's going to be all right. Just like it's not smart enough to convert 23.0 into 23. So it doesn't have to be like a genius challenge, right? It's just that the compiler will give up on certain things, and we are here to learn what it gives up on. What if we change that, and instead of doing O1.M2, we do O1.M1? Well, then that works. Because now method matching is able to check that it's a legit, call to the method. And dynamic binding is able to find that method in the superclass. So even for the object we have is of the subclass, when we look for the method, we explore, we look at the subclass, it's not there, we look at the superclass, it's there, bingo, I found it, and I'm going to run it for you. Okay, so we end up executing method M1 here. So, what did we learn so far? We learned that we can actually trigger a method from the superclass when we have a variable here that is defined of the superclass type. We cannot trigger a method of the subclass that exists only in the subclass. What about if that method is overridden from the superclass? So instead of having M1, M2 here, I redeclare M1 and I override the one from the superclass. Yes, that works. So there you go. That's the situation that we have so far. Okay? And we cannot get out of that without the second technique that I'm going to introduce now, which is downcasting. These are the limitations that we have to deal with until we introduce downcasting. So what is downcasting? Downcasting is casting down. And with that, we're going to close today. No, I'm kidding. So that means we go from a super type, from a superclass, to a subclass. We go from very generic, a university dweller, to very specific. This is a student. This is a cybersecurity student. This is a faculty. This is a research faculty. Okay? We go towards the subclasses. Here's a code example. So this time I declare faculty, student, and university dweller. Free reference variable. I haven't created any object yet. Now I create an object. New university dweller. So you see how sneaky I am. Now I'm creating an object of the superclass. Whereas in the previous example I was playing with object of the subclasses. So here I create a university dweller, and I want to assign A equal dweller, F equal dweller. This is the opposite of what I was doing with upcasting, right? So I have a university dweller actual object in memory, and I have all those possible references. I choose to look at it as a university dweller. So far, so good. And then I choose to look at it as a student and look at it as a faculty. Well, what kind of other university dweller lives on campus and know how to eat? Squirrels. So I could have an object of, I could have an object passed by polymorphism that is of class squirrel, a subclass of university dweller. It knows how to eat. And now I choose to look at this squirrel as a student or a faculty. That's going to make for some interesting lectures, that's for sure. But beside this, no, that doesn't make sense. So this is going to lead to compilation errors. Java is going to step in, and just like it stepped in and told us you cannot convert 23.0 to 23, it's going to step in and say you cannot convert something that is generic, a university dweller, to something that is specific. I cannot look at a university dweller as a student because I don't know if it has the method, learn. And I cannot look at them as a faculty because I don't know if it has a method teach. So that would not be safe. And that's enough for Java to stop everything. Okay? So there's not going to be any implicit downcasting ever. The same way that when we convert primitive data type, one of them is implicit always. The other one has to be explicit or is not going to happen. So let's use the syntax that we learned for primitive data type. We take parentheses, we put the name of a data type in the middle of the parentheses, and we use that to prefix an expression. And it's going to auto-magically convert that expression to the data type that's written between the parentheses. So what if I try to say S equal typecasting into student of dweller? So whatever reference I have in dweller, I choose to look at that object through the perspective of a student. And I do the same after that with faculty. That's enough to make method matching happy. Method matching just handed you a paperwork with a lot of fine print that said pretty much, this is never going to work. There's not a snowball chance in hell that this code is even half decent. But you seem to know what you are doing, right? So sign here, here, initial here, and if it breaks, it's on you. Okay? That's what we are doing by adding that parentheses notation, that explicit typecasting. So method matching is happy, and it says, sure, why not? You want to look at that object as if it's a student. You just wrote it explicitly, so you must really, really, really know what you're doing. I'm going to allow it. And then when you run your code, it's dynamic binding this time that's not really happy. Because when you run the code now, dynamic binding is going to say, are you kidding me? I just checked the type of that object, the actual type of the object. I didn't look at the reference variable and how it was declared. I looked at the object itself. And you are trying to get that squirrel to teach a lecture. Nothing is going to make sense there. I'm not going to be able to do that for you. Okay? That object doesn't have a method teach. Doesn't have a method learn. You can choose to look at it as a student or look at it as a faculty. Okay? Method matching lets you get away with that, but it doesn't make sense. It cannot happen. So that's a weird trick. We learn to bypass the safety check and still crash in the wall. So it's interesting from an intellectual perspective, maybe, not really practical. So let's try to make this practical. Let's try to show an example where explicit downcasting actually serves a purpose, makes sense, works. Faculty F, student S, university dweller, dweller 1, dweller 2. So this time I'm going to assign two objects to dweller 1, dweller 2. But look at what I'm doing. I'm not creating objects that are university dwellers. I'm creating objects that are one a student, one a faculty. So the actual objects, they are a student and a faculty. No more squirrels. Okay? But I choose to look at them from the perspective of a university dweller by assigning their reference to a variable dweller 1 and a variable dweller 2 that are just university dweller. I can do that. Polymorphism. Okay? And then later, I change my mind. I change my mind and I say, you know what? I know that object I created was a student, and I know that second object I created was a faculty. If I keep looking at them through a reference variable that is just university dweller, all I can get them to do is eat. I need them to do more. I need them to do things that I know they know how to do, like learn and teach. To be able to call those methods on the object, I'm going to have to change the way I look at them. I'm going to have to say it's official now. I'm looking at that first object as a student. So I assign it to a reference variable of type student, and I do explicit typecasting of the reference, not the object. The object never changed. It was a student all along, but I now look at it from the perspective of a student. I do the same for the faculty, and that is going to work. That is going to be allowed by method matching. This is going to actually work at runtime because what? Because of the way I wrote the code. And the way I wrote the code was I had a student all along and I had a faculty all along in those objects. Yeah?
What if we need more objects at runtime?
Oh, you can make as many objects as you want at runtime, but here's the catch. It's up to you, the programmer, to keep track of which one is a student, which one is a faculty, because after you assign them to dweller 1, dweller 2, if I have like 50,000 lines of code here between this and that, right, it's not that easy. But we're going to see a technique that allows us to kind of check what is a data type at runtime, okay? But right now, with what I introduced, yep, it's up to you to make sure. If you tell pretty much the compiler safety off, you have to be pretty damn sure of what you are doing. Okay, that's the rule with explicit typecasting among primitive data types. It's a rule with explicit typecasting among reference data types too. So it only works if the actual object, if you decide to look at a wall and say, I'm going to look at it as a classroom wall, sure. If you decide to look at a student and say, I'm going to look at it as a university dweller, as a student, all of those are okay, valid. If you try to look at a faculty as a student, it's not going to work. If you try to look at a university dweller object as a student or faculty, it's not going to work. And we are going to stop here, but what we are going to do next time is we are going to look at a new operator that's going to allow us to actually do what dynamic binding does. Dynamic binding checks the data type of the actual object, ignoring the data type of the reference variable. We have an operator that's going to allow us to do exactly that. So at runtime, we can check what the object is actually. Thank you for your attention. Yep, take care.